Welcome to A-Level and AP Physics. In today's lesson, we will discuss all electricity questions from Specimen Paper 1 for 2022 exam. For question number 29, it is given to us the diagram shows the symbol for a wire carrying current I. Means this is a wire and current in the wire is I. We need to find out what does this current represent. So first of all, let's try to understand what exactly current is. Current is equal to Q over T. And current, simply we can define current is the amount of charge passing through a point per unit time. Amount of charge. So Q is the amount of charge passing through a point per unit time. So Q is amount of charge and T is the time. So simply we can say current is the amount of charge passing through a point per unit time. Now if we have understanding of this one, simply you can see A is the right answer. The charge flowing past a point in the wire per unit time. For example, if you look at this point for 1 second, time is equal to 1 second. So the amount of charge passing through this certain point on this wire, if we divide that by time, we can find out value of current. So answer A is correct. Let's try to understand a little bit more about current. Now imagine that from this point, the amount of charge passing through this point in 1 second is 1 coulomb. Then current, simply we can say, means I, this is equal to 1 coulomb over 1 second. So this is equal to coulomb per second. And this is how we define 1 amp. Means 1 ampere is equal to 1 coulomb charge passing through a point in 1 second. If this is true, so current in the wire will be equal to 1 ampere. So in current, we talk about amount of charge. Now if you look at option B, this option is not correct because this is telling you the number of electrons. That in current, when we define, we talk about amount of charge. So option B is not correct. This is also talking about number of positive nuclei. Actually, positive nuclei do not move. Means ions, they do not move. So this one is also wrong. This is also talking about number of protons. This is also wrong because current is amount of charge per unit time passing through a certain point. For our next question, it is given to us an electric current I is given by the formula I is equal to A N V Q. Actually, this is transport equation. So let me write down the name of this formula. We call this one transport equation. Transport equation. Now question is asking us, what do each of the symbols represent for an electric current in a metal wire? Simply is asking you, what is A? A is the cross-sectional area. So A is cross-sectional area of the wire. N is the number density, or simply we can say is the number of free electrons per unit volume. So we can say is number of free electrons per unit volume. So this is what N is represented. Or simply we can say this is number density. So the N is equal to number density. We call this is number density because in this case we talk about number of free electrons per unit volume. But in simple density means the mass density. We talk about mass per unit volume. Now if you go to V, V is the average drift velocity of electron. Average drift velocity of electrons. So this is average drift velocity of free electrons. Q is the charge on single electron. Q is charge on single electron. Or simply you can say charge of electron. Charge on single electron. Now simply we understand the meaning of these symbols now. If you look at option B is the correct answer because this is area of cross section, number of free electrons per unit volume, and V is the average drift speed, average velocity, and Q is the charge of each electron. So B is the right answer. For question number 31, we need to find out which values of current and resistance will produce a rate of energy transfer of 16 joules per second. Rate of energy transfer simply means that power. Means we need to find out which value of current and resistance will give us power equal to 16 joules per second. Or simply you can understand this is 16 watts. Power we need to understand. Power is equal to P is equal to I square times R. Now if you get given values of I and R, I will be just talking about option D. Rest you can just check by yourself. If you look at option D, value of current is given. This is 4 amps and resistance is 1 ohms. And this is simply equal to 16 joules per second. So our answer for this question is D. D is correct answer. For question number 32, it is given to us a coil contains n turns of insulated copper wire wound onto a cylinder of diameter D. Diameter of the cylinder is given. It simply means that this is the diameter of the cylinder. So this is diameter of cylinder and this is equal to capital T. The copper wire has diameter small t. So diameter of the wire is small t. Resistivity of copper is rho. Diameter capital D is much greater than diameter small t. We need to find out what is the total resistance between the two ends of the coil. So very straightforward question. So we can simply calculate R is equal to rho L by E. Resistivity of copper wire is given. So simply we can say this is resistivity. Cross-sectional area of the wire we can find out. That will be equal to pi by 4 d square small t square because this is diameter of the wire. Now the problem is that how we can find out value of L. In order to find value of L, we need to find out the length of one loop of wire. And the length of one loop of wire, I will be writing here, length of one loop of wire. One loop of wire, that is simply equal to pi times t, means the circumference of the cylinder, pi t. So we can write down here pi d, but we have to multiply with n because in the question it is given to us there are n number of turns. So we will write down here this is pi d times n. We can simplify this one. If you look at this, pi we can cancel with this pi and we can further simplify. We can write down this is 4 rho n times d divided by small d square. Only difficult part in this question is to find the length of one loop of wire. If you can find this one, then simply you need to use R is equal to rho L by A. So our answer for this question is A. For this question, it is given to us two cells are connected to a load resistor of resistance 3 ohms. The electromotive force and internal resistance of each of the cells are shown in this figure. In this case, this is our load resistor. And you can see here we have two cells. EMF of one cell is 6 volts. Another cell has EMF equal to 3 volts. And these two cells, they also have internal resistance. We need to find current in the load resistor. Means we need to find out what is value of I. So the first thing we need to understand, these two cells are connected in series. So we can find out the net EMF. And also we can find out total resistance of this circuit because all these resistors, they are connected in series. So simply we can say in this case I means current. This is equal to total EMF of the circuit. So we can say total EMF of the circuit divided by R total means total resistance of the circuit. Total EMF is 6 plus 3 divided by total resistance 3.0 plus 1.2 plus 0.8. So this is simply equal to 9 divided by 5. So our final answer will be 1.8 amps. So the answer for this question is C. For question number 34, it is given to us the diagram shows a simple circuit. We need to find out which statement is correct. Actually, this question is based on internal resistance and very common question. You will see this one in many past papers. Let's try to understand when the switch is open and when the switch is closed. What is effect on terminal potential difference? We will discuss case 1 when the switch is open. So simply I will write down here. First of all, when switch is open. When switch is open, there is no current in the circuit. As there is no current in the circuit, if we connect voltmeter here, let's say we connect voltmeter at this point across the terminals of power supply. In this case, reading on the voltmeter will be equal to terminal potential difference. And the second second case, when we closed switch means when the switch is closed. When the switch is closed, there will be current in the circuit, means current will not be equal to 0. In this case, current is equal to 0 because voltmeter has very high resistance. So for ideal cases, we can assume that in this case, current is equal to 0. That in this case, current will not be equal to 0. Current will be greater than 0. So now if you write down the equation for EMF will be equal to the terminal potential difference plus V lost. From here we can find out terminal potential difference will be equal to EMF minus V lost. Or simply we can say in this case terminal potential difference will be less than EMF. Why is less than EMF? Because some of the energy has been used inside the battery or some work has been done against internal resistance. So that's the reason when we use battery for a long time, battery get warm because electrical energy is converted into heat inside the battery, means into thermal energy inside the battery. So some work has been done against internal resistance. So that's the reason when switch is closed, terminal potential difference is less than EMF. If you look at option C, it is given to us when switch S is closed, the potential difference across the battery falls. Decreases means this terminal potential difference when the switch is closed. Actually, if you connect voltmeter here at this point or you connect voltmeter across this battery, reading will be the same, and that reading we call the terminal potential difference. And this terminal potential difference will be less than EMF because some work has been done against internal resistance. Now simply you can say in this case some of electrical energy will be converted into thermal energy. Now it is given to us because work is done against internal resistance of the battery. So this one is correct option. If you look at option A, it is given to us when the switch is closed, EMF of the battery falls because work is done against the internal resistance of the battery. The EMF falls. EMF does not change. So this one is wrong. If you look at second option, same is given to us. When switch S is closed, EMF of the battery falls. No, EMF remains same, but terminal potential difference decreases. Now, if you look at option B, when switch is closed, the terminal potential difference, the potential difference across the battery falls because work is done against the resistance of R. This is false. This is wrong. So the answer for this one is C. For question number 35, it is given to us 6 resistors, each of resistance capital R are connected as shown in this figure. The combined resistance of all these resistors is equal to 66 kilo ohms. We need to find out what is value of R. Very straightforward question. So this resistor has resistance R. The resistance of this one is also R. Resistance is R. Resistance is R. Resistance is R. And the resistance of this resistor is also R. Now if you look at the first resistor, so it has resistance R. If you look at combined resistance of these two resistors, they are connected in parallel and they have the same resistance. So the total resistance of these two resistors will be equal to resistance of one resistor divided by number of resistors. Now simply we can say this will be equal to 0.5. Now if you look at combined resistance of these 3 resistors, 3 of them, they are connected in parallel. So the total resistance is equal to resistance of one resistor divided by number of resistors. Now if we simplify this one, we will get 0.33 R. Now you see we have 3 resistors now. Resistance of one resistor is R and resistance of the second resistor is 0.5 R and the resistance of third resistor, this is equal to 0.33 R. Now they are connected in series, so we need to find out total resistance. R total is given to us. R total is given to us, that is equal to 66 kilo ohms, and this is equal to 1.83 times R. From here we can find out value of R. Value of R will be equal to 66, this is kilo ohms, divided by 1.83. So the final answer will be 36 kilo ohms. So D is the the correct answer. For question number 36, it is given to us a cell has constant electromotive force and constant internal resistance. A thermistor is connected between the terminals of the cell. The temperature of the thermistor is increased. We need to find out which statement about the change of the cell's terminal potential difference is correct. So first of all, let's try to sketch the circuit. In this case, we have cell. It has a constant EMF and it also has internal resistance. So this is the internal resistance. And there is a thermistor that is connected between the terminals of the cell. It simply means that it is connected across the terminals of the cell. This is connected across terminals of the cell. So this is our thermistor. EMF of this cell we can say is E. So if we draw our cell, so this is what you will see physically. So this is the positive terminal of the cell. For this question, it is given to us, we increase temperature of thermistor. So when we increase temperature of the thermistor, resistance of thermistor, it will decrease. When resistance of thermistor will decrease, current in the circuit, it will increase, because current is equal to EMF of the cell divided by resistance of thermistor plus internal resistance. If resistance of thermistor go down, EMF is constant, so it means current in the circuit will increase. If current in the circuit increase, then we can simply understand EMF is equal to I times capital R plus I times small r. In this case, you can say this is terminal potential difference. So this one is terminal potential difference. So we can simply write down this is VT, and this is equal to EMF minus I times R. For this question, it is given to us that EMF is constant, so this one is constant. R is also constant. If current increase, it simply means that VT will decrease. So the terminal potential difference will decrease because work is done against internal resistance of the cell, same as we have discussed before. Now, if you look at option A, it is given to us the terminal potential difference decrease. So this is true. Why decrease? Because more work is done. Because more work is done due to more charge passing through the internal resistance. So that's the reason more work is done, moving the unit charge through internal resistance of the cell. So option A is correct. So this is correct option. If you look at option B, it is given to us terminal potential difference is decreased because current in the thermistor is decreased. Actually, current increased. So this is not the reason. So option B is not correct. Terminal potential difference increased. This is incorrect. Terminal potential difference increased. This is also incorrect. So the answer for this question is A. Terminal potential difference in this case decreases because current has increased. If current increase, it means more charge is passing through internal resistance. So more work has to be done. So that's the reason terminal potential difference decreases. For question number 37, it is given to us a battery with negligible internal resistance is connected in series with a resistor and a light dependent resistor LDR as shown in this figure. The light intensity of LDR is decreased. So the first thing we need to understand, when the light intensity decreases, if the light intensity decrease, resistance of LDR means R LDR, this will increase. So this is the first point we need to understand. If resistance of LDR increase, now we need to understand what is effect on voltmeter reading, means what is effect on VQ and what is effect on VP. This is what question is asking us. How do the readings of the voltmeters change? Let's try to understand what is the effect on current in the circuit. So we can simply say I is current in the circuit. So I we can simply calculate by dividing EMF of the cell by the total resistance. Mean resistance of P plus resistance of Q, means RQ is the resistance of LDR. If resistance of LDR increase, it means current in the circuit will decrease. If you look at EMF and the potential difference across P plus potential difference across Q, EMF of the cell is constant. If you look at VP, so simply we can write on VP here. VP is equal to I times resistance of RP. In this case, resistance of resistor R is constant. So if I in the circuit decrease, it means Vp will decrease. If Vp decrease but EMF of the cell is constant, so it simply means that Vq will increase. So the potential difference across this one, LDR will increase, but potential difference across resistor R will decrease. So based on this one, we can find the answer. If you look at option A, decrease, this is right. Decrease, this is incorrect. If you look at option B, voltmeter reading on P decrease, this is correct. Voltmeter reading of Q increase, so this is also correct. Answer is B for this question. Increase, this is wrong. Increase, this is wrong. So C is incorrect. D is also incorrect. So the answer for this question is B.